So in our yesterday session, we started discussion more about annotations. So what is an annotation? How annotations are going to be created or how annotations are going to be worked. So those are all details we had a session in yesterday point of view. So simply, what is the purpose of annotations we will use in our programming languages to provide an information about the of the source code. Simply, whatever the source we are implementing, whatever the logics we are going to implement going further, to provide more information about our logic, we will use annotations. So earlier, annotations comes under the part of configuration generally. So you will configure something, you will inform, okay, you will provide extra information, configuration of the data. So that is how generally we used to do earlier other ways, but to avoid those problems and all, so Java came up with annotations, and annotations is a very important thing. And without annotations, you can't understand going further other frameworks or all this because nowadays everything is implemented based on the annotations only. Okay. And so it's all about that's what annotation is all about talking about metadata means you're providing more information about the classes, methods, fields, what you implemented as part of your classes. Are based on the framework, we will follow the rules and regulations, and based on that, we will define the annotations to make sure the features of framework is going to be work as part of our application. So that is how we are going to use the annotations. So we understood actually yesterday. So how annotations, what are the rules we have to follow? How we annotations are going to be created? So in case whenever we want to create our own annotation based on our requirement perspective, so we can create our own annotation by using interface keyword only. But only thing is you have to use @interface approach. So whenever you want to create an annotation, public @interface, and then you are going to create the annotation. So it's similar to creation of interface only. So that's why they used a interface keyword, but only thing is you have to use symbol before the interface. And after that again I said, so if you want to make sure the annotation usage configure, what is the purpose of that annotation and all, you have to define again two things. One is retention policy, second one is target type. So retention policy is saying like that annotation belongs to only source code level, or is it that annotation is passing any information to the compiler, or that in at that annotation you are going to use for passing an information to the Java runtime level. So it's all three levels of retention policies we will have. So if you define source, that means the annotation whatever you created by with source retention policy, that annotation just used only for the while you are implementing. So that means simply I can say that that annotation lifetime is until you are writing the source code. But the moment you used as a class, that means dot class file point of view, they given this word. So it is then that annotation is used by the Java compiler. So that means the lifetime of that annotation when you whatever you used as part of your logic or whatever you created, so it is going to be used until compilation phase, until compilation phase, until compilation phase. Now similarly when you given runtime also, what will happen now, that annotation by using that whatever the annotation we are using, that is passed until JVM level. So that means until execution phase we will use that annotation, that annotation is being passed. But generally, I said yesterday also, 90% we will use always predefined annotations. 5 to 10% only will get a chance to create our own annotation based on the requirements. But very rare case we will create our own annotations because nowadays mostly every programming language, I mean, with respect to Java language, every library, every framework is implemented their own annotations for every purpose. So it's all about just identifying and using. But we should know when we are using annotation internally how it is implemented or how it is working, and we should know that annotation being configured at what level and all. Now, if you go to the second thing, target. So if you see here target again, so target is talking about that annotation what we created being defined at what level. So if you whenever I created yesterday annotation, I given like I configure target at method level, type level, field level. So what is the point of method level, type level, field level means this annotation now at the rate first annotation, I can configure at method level, element level, sorry, type means class level as well as variable level, field means variable. So whatever based on the whatever you define here, based on that only you can define. For example, if you see based on our yesterday discussion, if I remove a field, so that means now this annotation you can use only at method level and class level, not at variable level. So see here, now you got an error at a variable level. So that is what talking about target type. Retention policy talking about only that annotate by using that annotation. Okay, you are using that annotation lifetime until source level or until compilation level or until runtime level. You are telling that. So that annotation is going to be considered like that. Okay, so that is how you are going to create the annotation. So whenever you want to create attributes for the annotation, so that means now, for example, if I created my annotation like this is having zero attributes. So that means this is how simply you will create an annotation and you will use it. So there is no annotations for this like this. If you just assign the annotation, that's all. There is no attributes. But if you want to add any attributes to your annotation also, based number of attributes or whatever it is, simply you have to define kind of abstract methods here. Okay, integer, for example, I created like value 1 and it should be like in the format of abstract method point of view. Now, the moment you created an abstract method point of view, what will happen? Now, this value 1 became as a attribute for that annotation, and if you want to configure those values also, you can configure here. Value 1 equal to something 10. Why I am able to give 10? Because it's an integer value. I given as integer. Now if I given string name equal to name like that I given. So in such case again, what if you go here? So you have to configure one more property, comma. So name equal to, so string values you can provide. So the moment I provided values, string values, all these things, I'm able to, that annotation got compilation is getting success because those became mandatory in this case. Okay, those became mandatory in this case. So that is how you are going to understand. We have to understand the annotation, and it's all about in future. Definitely from today onwards, you will see a lot of annotations. So whenever you have any idea, you want to know more about that annotation, open source code of that annotation. Then you will understand what's being happened and all. For example, today, right now, I'm going to start a topic called as what? Functional interfaces. Yeah, now let's start our new topic called as functional interfaces. And I'm telling you one more time before entering into functional interfaces, please understand this point as a note, whatever it is. Nowadays, if you want to understand things very clearly, if you want to make sure your knowledge is more strong, and if you want to make your knowledge more strong in the Stream API, so there is a concept called as Stream API. So without Stream API nowadays, nobody is writing the programming, and without Stream API interview questions, you will not get an interview chance also. You cannot clear interview also, and as well as not only Stream API. Nowadays, there is a concept coming, some kind of reactive programming, all these things coming. So to understand all those things, functional interfaces became a fundamental concept. Functional interfaces became a fundamental concept. And extended to functional interfaces, concept we have called as Lambda expressions. So there is it's all functional interfaces and Lambda expressions. So these two concepts, you have to be very strong, whether you are experienced or fresher, whatever it is. But if you are missing these two things, what and all happening and all, what's a point and all, you cannot understand Stream API properly. So that is how the things will happen. So just concentrate These are more important, not only here, in other ways also these things are very important, because these are all added from Java 8 version. Again, I am telling you again, this is added from Java 8 version. So that's why these things will be called as Java 8 features. Yeah. Generally. Until Java 7, we don't have a concept called as functional interfaces and Lambda expressions. These topics are supported from Java 8, and Stream API is also supported from Java 8 only. Okay. So what is a functional interface? What is a Lambda expression? So how we are going to implement the Lambda expressions? So let's start understanding from the functional interfaces. So then at last we will see the Stream API when we started a collection framework. Okay. So now let's understand what is a functional interface, and then we'll start about Lambda expressions. Okay. So what is a functional interface here? So we know interface generally. So when we understood what is an interface means, interface is okay, we are going to create a type called as interface, and that interface is always contains mostly abstract methods. That means by using that abstract methods, we are going to create or make and implemented classes for that interface. So that is what we understood. So an interface is all about a group of abstract methods. An interface is all about a group of abstract methods, as well as now you know the concept of static methods as well as default methods also. Default methods also. So right, so we know all this concept. So we can add here abstract methods means you can add greater than 0. I will add like this 0 or not. So that means in a regular interface, we can add any number of abstract methods. We are already done that part also. So if you, whenever we understood the interfaces, so we are already done that part. So that means if you open any interface, we can add more than one abstract method. We can add more than one abstract method. Let me open that interfaces. Yeah, so this is an interface. How many abstract methods we have here? It is 1, 2, 3, 4. So 5, I mean, it's all about like that. So I have more than one. Even I can define 0 also like that. So that is what a regular interface. That is what we understood. But now today we have a concept called as functional interface. So what is the point of functional interface here? It is understand the point. So single abstract method, understand, single abstract method, that whenever an interface contains single abstract method. Okay, so again here static methods and default methods is up to our choice. I mean, it's all about we can add. Okay, here in this case static methods also generally in a regular interface we can add 0 or more. Default methods also 0 or more we can add. Okay, but when it comes to functional interface point of view, what is going to happen here? It is okay, so here only one abstract method, you have to, one abstract method should be. So understand the point. Okay. Okay. So in this case, one abstract method should be available. So that means in earlier case, what happened? In an interface, you may maintain 0 interfaces also. It's up to our size 0, 1, 2, 3. But in a functional interface point of view, you have to make sure 100% one and only abstract method is available. Not 0, not more than 1. So only one abstract method should be available, as well as when it comes to static and default methods, it's up to our choice again. So that means what is the difference between a regular interface versus functional interface is, in an interface, we may create n number of abstract methods or 0 also. But when it comes to functional interface point of view, that functional interface must and should contain one abstract method, only one abstract method, not more than 0, I mean more than one. even not 0 also. So one abstract method should be presented. So that's why when it comes to the functional interface point of view, so what is the definition we can take here? It is a functional interface is an interface that has only one that exactly have, or I can that exactly have only one abstract method, one or single abstract method, whatever it is, single abstract method. So a functional interface that exactly have only one or single abstract method. So it should not be more though. So that means the rule what you have to understand here it is, what is the thumb rule or whatever you have to remember here it is, note. It should not be 0. That means no, it should not be 0 or not more than one method also. Not more than one method also. So only this rule applicable for abstract methods, guys. Again, if you want to add static methods and default methods, whether 0 or more, four abstract, I mean 4 static methods, 10 default methods, there is no problem in that case. But only with respect to abstract methods point of view. So that means where you don't implement the body, only signature you will define. So that should have only one abstract method. So that's why. So that's why generally these interfaces, functional interfaces, is called as SAM interfaces also. Yeah, SAM, yeah, SAM interfaces. SAM interfaces. What is the point of SAM here? It is this is what full form. I mean single abstract method. So these interfaces, functional interfaces, we sometimes people will call it as SAM also. SAM interfaces, nothing but single abstract method, but generally main terminology is functional interfaces only. Okay, so why? What is the reason behind making an interface contains only one abstract method always, not 0, not more than that, like a regular interface? When already some regular interfaces concept is there from Java version 1 onwards, then why they came up with functional interfaces similar to regular interfaces, but only thing is they made some rule here available some single abstract method point of view and all. That is the concept we have to understand going further. What is the purpose of single abstract method as part of interfaces and why we are calling that specially as a functional interfaces, and what is the purpose of it we have to understand now. Okay, so we'll understand step by step process why exactly Java introduced these things and all. First, let's concentrate on the rules and regulations. Then, purpose why Java is introduced. What is the purpose? What is the reason behind interface versus functional interface point of view? We will understand conclusion after knowing a couple of other things also. Okay. Okay. So now next. So let me create an interface first, and then let's try to understand what's happening here. It is. Sorry. Okay. So now I taken functional interfaces. Let's create a interface. So I'm just making a package name. Okay, then let's create a interface name. So let me take a proper interface name in this case, and then we'll try to understand. Hmm. Okay, basic example I'll take first, and then so that we can understand easily. Then I'll improve some real time complexity point of view also later. Okay, so my point here it is just calculator operation, something like that. Addition subtraction point of view. That's why I taken this. So now this can I call right now this as a functional interface means 100% answer is no. So is this functional interface means answer no. Is this functional interface? Answer is 100% no. So our answer is no. Why? It is violating a rule called as, what is the rule? Functional interface should contain only one abstract method. S- That's why those called as single abstract methods also. Here zero abstract methods. So that's why you cannot call it as. Now if you take an again, in this case, if I added anything like, okay, um, integer add integer a comma integer b, something like that I taken. Now I'm adding one more abstract method, integer subtraction of a comma b. So now can I call is this as a functional interface means again answer is no. Answer is no. Now when can I call this as functional interfaces is, so now can I call this as a functional interface means 100% yes. Answer is yes. So why? The rule is, what is the rule we remembered? Is it should contain only one abstract method. It should not be zero. It should not be more than one. So only one abstract method it has to contain. After that, you may have or may not have static methods. That to n number of static methods. Static and default methods you may add as part of functional interfaces. Okay, you may add more than one zero also. There is no confusion about. Don't keep any confusion. Okay, the story is all about single abstract method, guys. So that's why you remember this word. Then story you can remember easily. Single abstract method, SAM interfaces. So here only story is available about one abstract method point of view. Yes, it is a functional interface is now. So can I can call it as a functional interface. Okay, cool. So let's make same method add, and I'm taking integer value 1 comma integer value 2 something. I defined an abstract method like this. Okay, fine. Now I'm calling it as a functional interface. Okay, cool. Now, tomorrow, what is the guarantee? Assume you are working for a real time project, and generally, real time projects run, will run for years and years. So, you thought like it is as a functional interface. You remember the rule and you made like it's as a functional interface point of view, single abstract method only you added. Okay, and you made the purpose of functional interface point of view. So why? What is the purpose of functional interfaces? I'll tell you that reason and all. I'll explain later why generally this is all Java given this entire story and all. We will see that story I'll give you later. Okay. So now you thought like it is a functional interface, but what is the guarantee of someone else will not come and add another method like this? Maybe. So tomorrow one more developer came and he thought like, okay, I have an interface called as calculate operation. So maybe he want to implement some subtraction functionality. So he utilized this interface itself instead of creating. He utilized same interface itself. Now, like for example, I added one more abstract method. Now, what happened in this case? No compilation error, because in a regular interface perspective also you can add more than one abstract method. There is no, okay, there is no stop for that. That's why you are able to add it. Then that means in this case what's happening, you are breaking the functional interface nature. You are breaking the functional interface concept by added one more, what, one more abstract method. So then what we have to do, the moment functional interface point of view, whenever it is added one more abstract method, one more, whenever we are trying to add one more abstract method, or when we are trying to delete existing single abstract method itself, I have to make a warning, I have to make a error like, hey man, this is the interface you created as a functional interface, so that's why you should not add more than one abstract method, or you should not make zero abstract methods as part of your interface. Like that, I have to make a warning or a an error. The moment you made like this, also you have to get an error. Or the moment you added one extra abstract, I mean, you added more than one abstract method also, you have to get a compile time error. So for that purpose, what Java is did in this case is to define. So in this case, what Java did here, it is when we define single abstract method, okay, I'll write sam word. Okay, when we define single abstract methods as per functional interface point of view, okay, to make sure that interface is always as a functional interface, okay, so the java provided an annotation called as at the rate functional interface. At the rate functional interface. Okay. So in interviews they'll ask you. I mean, sometimes, what is the difference between a functional interface and normal interface? Means whatever the story I explained now, as of now, you have to make sure that. So sometimes they will give. Okay, I'll come back to that point. First, let's understand this. Now see here what I said. Whenever we have to make sure your interface is always as a functional interface, Java provided an annotation called as at the rate functional interface. Java provided an annotation called as at the rate functional interface. So that means what this annotation is going to do in this case is, yeah, this is the interface name. So what this annotation is going to do is, it will ensure like an interface contains always only one abstract method, only one abstract method. This annotations make sure like that. So that means this will give a compile time error. So that means this annotation is giving an error to a message information to the compiler like, hey compiler, in future, if anyone added an interface to this interface, I mean, if anyone added more than one abstract method or zero abstract methods, make that interface compilation as failure. Like that, this annotation is passing some information to the compiler. So that means you don't need to create this annotation. This is already given by the Java language. So let's see here. What is that annotation? Functional interface annotation. So this is from which package? From java.lang package only. Okay. So this is from the java.lang package. So package is also from the default package called as java.lang package. Now understand the importance of this annotation. So now see here, I have one abstract method. That's why I'm not getting any compile time error. So now I remove this abstract method. So what happened immediately? You got an error. Compiler is giving an error. Hey man, you declared this annotation as a functional interface. So that's why 100% you have to maintain only one abstract method. So that's a guarantee like that. It is giving the error. See, invalid functional interface. Calci operation is not a functional interface. Why? You are violated the rule. That what is that rule? Maintaining only one abstract method. So now I added again one abstract method. So one abstract method, that's all. Whether irrespective of signature, one abstract method I added. So now this is a functional interface. Okay, now I added one more abstract method, more than one. Not zero, not more than one, but I added one more also, like subtraction. What happened? Again, you got the compile time error. Why? Again, that's what, right? If it is a regular interface point of view, we are not added any annotation. That's why you are not getting any compile time error. See, you can add 100 methods now. You can add 100 methods now as a regular interface abstract methods point of view. But now the point in this case, functional interface point of view, the moment you made this at class level, what? So it will ensure always only one abstract method available as part of this interface. So that's why the moment if any developer are trying to add one more abstract method by considering this as a regular interface, then what will happen in this case is you will get compile time error always. So that is the point I given here now. So this interface ensures always interface contains always only one abstract method always. Okay, so that is how this we are going to create functional interfaces here and all. But what is the purpose? I will see why Java specially given this when we are already have a regular interfaces point of view and all. That conclusion point of view I'll give you. Only rules and regulations point of view we will discuss today. Okay, fine. Now I defined somehow. Now how to provide implementation for this functional interface. Generally, in general, okay, leave about functional interface and all. If I have a concept called as if I have a concept called as interface, then what we will do, we will provide a implemented class. So that means we will write an implement class. So that means what we will do, we will write a implemented class, and as part of that class, we will provide implementation for all abstract methods. That's what we will do generally. Write an implemented class and provide implementation for all abstract methods. Now in this case also, for example, I want to provide implementation for this interface. So what we can do, I'll write a class, something like calc or whatever it is, and main method point of view I taken. Okay. So here, let's see here. Now, what is the approach we know? We will take a class and we will try to make sure implements, and then interface name is called as calc operation. So the moment you are implementing, what is the rule? You know that you have to provide implementation for all all abstract methods. Yes, it is having one abstract method like addition. Yes, that is what you have to provide here. It is okay. Now I am providing logic for this method also. Something like value 1 plus value 2. This is a approach we know that providing implementation for an abstract method of interfaces. Now you can call this what? You can create object for the calculator class equal to new calculator, and you can call them. This is the regular approach. This story we know that just providing what. Okay, so this is the regular approach we know. So now we can execute. What is the one point we understood right now? Here it is in the overall discussion how to create a functional interface. But implementation point of view, regular approach we follow. But this is the okay. This is the regular approach. This is the old approach, like writing an implemented class for an interface and providing the implementation. Okay. So, but if this is the real way of solution, then I don't think Java introduced a functional interface concept. Okay. So if really as a developer is provided implementation in such a way like this, then I don't think Java introduced a concept called as functional interface. Rather, okay, already when interfaces are there. Okay. So here the main purpose of introducing functional interfaces here all about is there is a concept available, functional programming. Okay, functional programming, and there is a concept available as again declarative programming. I'll give a small overview later. Okay, what is the functional programming? What is the declarative programming? Um, I'll forgot one more word. Declarative. I forgot one more word. Yeah, imperative programming. Okay, so declarative versus imperative programming. What is declarative? What is imperative programming? We will see later. Okay, so actually, in this case, to achieve the declarative programming point of view, so if you see here overview of declarative and imperative programming, I'll give you very overview. I'm not going to discuss much about it. It's a generally a theory concept. See, the main difference between declarative and imperative programming is that declarative programming focuses on what you want to do, while imperative programming focuses on how you want to do. Okay, leave it. I'll simplify this process later. Okay, let's do one thing. Java is, let's understand this. So Java is a imperative programming language. So Java is a imperative programming language. So that means what is the point here? It is, if you understand this point now, imperative programming means generally what will happen is a statement at a time point of view. So generally, I know that, right? We know that, right? When main method is executed, internally what Java will do, it will execute line by line. So whenever you are calling a method like ABC method from the main method, what it will do, it will ABC method, jump to ABC method implementation. It will jump to ABC method implementation, compilation or execution point of view. Once this ABC method execution is finished, what will happen? Again, JVM will come back to this line, next line. So that means next of this line. So line by line point of view, everything will happen. That's why that is what they are saying here. It is declarative programming is somewhat okay. You are going to make a relationship between inputs and outputs. Instantly, you are doing something over there itself. That's what I'm telling you. So you don't worry about all these things. But generally, to achieve declarative programming as part of Java language, they came up with this concept. Okay, functional interfaces. To achieve that concept, again, if you are following this regular approach, like providing an implemented class for a functional interface, and you implemented a separate Java class again for functional interface also, it's a regular concept. Then there is no point of, in this case, calling it as a, I mean, some real, I mean, something new is not available in this case, except added this annotation. But the purpose of introduce of this is all about to achieve the declarative programming in this case, actually to achieve declarative programming. So you will understand how it is a declarative programming and all, we will understand later. That's why I'm telling you. At last, we will make a conclusion. So in this case, generally, Java provided a concept called as Lambda expressions. So what is that concept here? It is Lambda expressions. So that means what is the purpose of Lambda expressions here? It is okay. So now in this case, what Lambda expressions are doing in this case is, yeah, give me a moment. Yeah, sorry. Yeah. So in this case, what is the purpose of Lambda expression and why, how we are going to, what is the, how we are going to create Lambda expressions, why it is called as expression also, we will try to understand. Okay. So here generally understand the point. The moment we created functional interfaces or the moment we are having functional interfaces implementation, functional interfaces implementation, we have to make via lambda expressions. We have to make via lambda expressions. We have to make via lambda expressions. So that means in this case again, that lambda expressions, whatever the word we are using, lambda expressions, okay, is always an implementation, of functional interface. So that means whatever the way we provided the implementation right now in the regular approach, like provided a new class, and inside that class, okay, I implemented again functional interface and then provided a method. It's not the regular approach. Is encouraging by the Java language with respect to functional interfaces. In a regular interfaces point of view, this is the approach only we have to follow. Like you have to take a implementation class and implement the interface and write logic for all abstract methods inside our class. But with respect to functional interfaces point of view, okay, we have to provide implementation always as a lambda expression. If you are providing in this approach, no one will stop you. Your program will work. But the thing is, it's not recommended. That is what I'm trying to say. So, what Java is recommending in this case is make sure whenever you are having a functional interface as part of your application created or whatever it is, predefined functional interface or user defined functional interface, you have to make sure providing implementation always by using a concept called as lambda expression. So that's why I said functional interfaces implementation we have to make via lambda expression rather than a regular implemented class approach, rather than a regular implemented class approach. And that means the lambda expressions are always the lambda expressions are always an implementation of a functional interface. So if there is no function, so you can remember like this: if there is no functional interface concept, there is no lambda expression concept. There is no lambda expression. Simple rule. So whenever the moment you hear lambda expressions going further, that means behind there is a functional interface. In a regular interfaces point of view, you can't use the lambda expression. Okay, but what is a lambda expression you don't know, but I'm just theory points I'm making right now. We will enter into practical. So I'm just making a easy note, like if the moment you hear lambda expression means definitely there is a functional interfaces existed behind that lambda expression. So if without functional interfaces, there is no concept of lambda expression, or at least single abstract method. That's why I said single abstract method interface. So lambda expressions always, okay, I'll write that point. So lambda expression always an implementation of single abstract method of a interface. So that means if you go here, yeah. So this is the interface if I taken. I can provide implementation in a way of lambda expression for this interface. Why? You cannot say like, sir, there is no functional interface annotation here, so that's why we can't do that. We can do that. We can do that. But only thing is that interface contains only always one abstract method. But why we are adding annotation in future, some other developer or some other way, we have to make sure or restrict. Okay, anyone else cannot add a new method or anyone else cannot delete existing abstract method to protect such a way like this interface never ever being added by a new abstract method or being deleted by existing abstract method. We are going to add a functional interface. So that means now the moment you are having this, and if you are added here at the rate functional interface, both are same only. Now in this case, this one both are functional interfaces only. But what is the beauty of, I mean, what is the concept of added this annotation? What it is making in this case is at the moment both are functional interfaces only. But tomorrow, assume a new developer joined or maybe someone else or whatever it is. So he thought like, let me add a new abstract method. Yes, it is allowed here. But when other person is trying to do here, it is not allowed. So that is the advantage of adding this functional interface. So that means this interface is always protecting this annotation is always protecting this interface contains only one abstract method. But in a way, like you created only one abstract method interface without annotation also. Okay, I can call it as functional interface until and unless someone else not deleted this or someone added this, then I cannot call it as a functional interface. But you can't restrict another developer. So the developer doesn't aware of it in a real time application, or you left the organization. Your purpose you thought in your mind like, okay, this is a functional interface, and you implemented based on that. But other developer joined and he felt like, okay, so he knows that what is a functional interface also, but you are not added here annotation. So that's why he felt like, okay, let me utilize this annotation and let me utilize this interface, like that he added a method here. It you will so the moment we are added here, you will not get any compile time error. Then you will feel happy and you will just, I mean, it's all. But in this case, you made an annotation, then that's why it's not allowed to add another methods. But when it comes to lambda expressions point of view, I can provide implementation for this one as well as this one also. Why this one? It's have only one abstract method at the moment. So here it is always only one abstract method because you added a functional interface. So to overcome all these problems, generally it's better to define always an annotation called as functional interface, so that 100% is never ever zero abstract methods or more than one abstract method is available because you added this annotation. So that's why simply lambda expressions are always an implementation of a single abstract interface methods. Single abstraction of a single abstract method. A SAM means single abstract method of an interface. So what I'm trying to say here, let's try to understand now. Okay, let's take functional interface only now. Okay, concentrate, very important, and it requires some attention also, because a new way of style you are going to write now. Okay, so this is the functional interface we decided now. Now I'm talking a new, okay, now we are having a clear picture what is a functional interface rather than I'm comparing with a regular interface. Okay, now I'm talking more about lambda expression. So what is a lambda expression in this case? Let's try to understand. So it's a functional interface, and what is a lambda expression in this case is, okay. So what is the point of lambda expression? What I'm saying, lambda expression is always an implementation of single abstract method. An implementation of single abstract method. So this is the point you have to remember. An implementation of single abstract method. So what is the point of single abstract method in this case? This is the single abstract method you have here. This is the single abstract method of this interface. So that means by using lambda expression, whatever you are going to do right now, I mean, that will become always an implementation of this abstract method. So nothing but what is going to happen with respect to lambda expression here, it will become an implementation. What is the meaning of implementation? You know, right? Providing method implementation, nothing but opening the curly braces and you're providing the logic. This comes under the interface, sorry, implementation. Now if you go to our regular approach in this class, what you did, you implemented interface, nothing but what implemented interface is nothing but what you did, providing implementation for all abstract methods. That is what the concept of implementing an interface is, nothing but providing logic for the interfaces. Sorry, providing logic for the abstract methods. So here in this case, add is an abstract method, and in the class, the moment you implemented an interface is nothing but what you provided logic for this add method. You provided logic for this add method. Now, whatever the implementation, so that's what I'm saying, like implementation. And this is the regular approach. This is a regular approach. This implementation is a regular approach. Now, what I'm trying to say in this case is, yes, whatever the implementation, nothing but assume this is the only implementation. So this will comes under the, okay. So here, whatever the logic, you are making for that abstract method point of view, that lambda expression denotes always an implementation of abstract method. But how to write lambda expression and all, we will come back. Simply, the moment whenever you heard as a lambda expression is nothing but what is, by using lambda expression, you are always providing implementation for this single abstract method, for this single abstract method of an interface. So if you are having a regular interface more than one abstract method or zero abstract methods, then again lambda expressions will not work. So that's why I given lambda expression is always an implementation of single abstract method of an interface. So that means for this also I can implement the lambda expression. For this also I can implement the lambda expression. The reason is it's having only single abstract methods in this case, in this case. But functional interface point of view, 100% is always you have a guarantee available always single abstract method. But here you don't have a guarantee. I can delete or I can add more than one also. So that's why there is no guarantee. So such a way, that's way, so it's, we can't make sure always there is a guarantee of implementing lambda expressions for a this kind of interfaces without annotation of functional interface. Okay, now it's okay. Finally, we understood like what we understood my overall discussion. It's better to, I mean, it's make sure always an interface as a functional interface means add an annotation, nothing but it is always provided a single abstract method, nothing but by you for that single abstract method implementation, you will always use lambda expressions. So that is why I said a word like going further. If you heard anywhere else lambda expression means behind lambda expressions, you have to understand there is a single abstract method interface, nothing but functional interface. So that's why the summary is lambda expression is always an implementation of a functional interface. Okay. So now how to write lambda expression. Okay, we understood something like the relationship between functional interfaces and lambda expression. We understood something like the relationship between functional interfaces and lambda expression. So what is the lambda expression is? Lambda expression is always an implementation of, I mean, simply by using lambda expressions, we are going to provide implementation of single abstract method of an interface, that of an interface. So why it is called as lambda expression? Why not some other expression? What is the purpose of the given word here? It is, I don't know exactly, but I just felt like this one. You know lambda symbol, right? I think if you go here, a lambda symbol. Okay, so hmm, I think this is the symbol. Yeah. So I don't think, I mean, I'm not sure if I'm right or wrong, I'm not sure. But I felt like this is what the whatever the expression we are going to understand the syntax or whatever it is. I felt like it looks like this way of signature or this kind of look and feel wise it looks like this, that might be they given lambda expression, something like that, but I don't know the story why they given, but I felt like whatever the lambda expressions we are going to define now for this functional interfaces and abstract methods point of view, that syntax looks like this in this shape, that solution of lambda expression whatever what we are defining now for this, that solution looks like in this shape. So probably that's why they, I thought like they given as a lambda expression point of view, but I don't know exact reason. If you know anyone, just identify. Okay. Okay, leave it. I just given. So this is the way they given lambda expression. Okay. So let's understand our way in with respect to how to implement the lambda expression, how to write or implement whatever it is. Okay. So see here. So syntax I'll give you first. And this syntaxes requires a lot of practice, guys. I'm telling you again, to implement the lambda expressions, you can't achieve within 1 or 2 days writing a good lambda expressions. It needs a lot of practice. As an experienced people also, still people are going to get confused to write lambda expressions for a functional interface point of view. So that much, it's not again difficult also. There is, you have to understand very clearly the rules and regulations point of view. That's all. But anyway, I'll give you all the ways. We'll try to understand. I'll take different methods and I'll implement all these lambda expressions. We'll see that. Okay, so what is the syntax of lambda expressions? Here it is. So parameters, method parameters, nothing but method parameters followed by an arrow symbol, followed by an arrow symbol, and then here you are going to make sure providing a logic like this. So here in this case some logic will come. I'll come back, I'll explain you very clearly what's happening in this case, and all we'll see that. So somewhat that's why I told you, okay, the symbol based on, I mean the solution looks like somewhat in this shape. I mean I don't know why they given lambda expression, but I felt like that. Okay, the syntax of lambda expression somewhat comes like this. Let me explain you very clearly again in this case. What is the point of syntax in this case? Hmm. This is one way of syntax. I mean, shortcut syntax also will have, but when you have only one line, I'll come back with example by example. Now let's take first functional interface and then we can understand easily lambda expression. Okay. So I'm taking this functional interface now. Okay. This is the functional interface. Cool. Okay. Leave about this. We will discuss this later. Yeah. Now it is a functional interface, nothing but single abstract method. Okay. Cool. Now for this single abstract method, understand always guys, please remember again, I'm telling you one more point, one more time. You have to concentrate, your focus is always concentration on this abstract method. Single abstract method, SAM, I'm saying single abstract. So your focus should be always on this method with respect to functional interfaces point of view. So now in this functional interface name is calculator operation, and that functional interface is always, I mean, have a method called as add method. That means it will take two integer values and it will return integer value. So in such a way, in such case, how we are going to write the lambda expression? And lambda expression, why they given word as expression also I'll tell you. Why they given expression concept I'll tell you. So here I'll give you one point. What is that point is? Yeah. Lambda expressions don't require don't require a separate class. Lambda expressions don't require a separate class for implementing an abstract method of functional interface. An abstract method of functional interface. So what is the point I'm trying to say here? It is in general, what we did, we taken a new class and then we added implementation for that abstract method in a old approach. In this case, you taken a new class. For example, now I ask you with respect to old approach point of view, hey man, can you please provide implementation for this method? What you will do immediately? You will create again one more class. You will create again one more class. So already one logic is there. I said I want one more logic for the method. Then what you will do in the second approach? You can't provide one more logic one more time here. Like I will add again one more time overriding. Okay, you can't do two times same thing again. It will not come. So that means I want one more logic implemented for that functional interface abstract method. Then what you will do? You don't have any other option other than creating one more new Java class. So what you will do is you will create one more class called as calc2, and then you will make sure like then you provided implementation. So that means in a regular approach, what you are doing, you are making like a new class you are creating every time when you are provided a new implementation for that abstract method. Now you will write logic here. Now I said now I want one more logic. Then again you have to create one more class. So that means different types of solutions for the same abstract method, you have to create different classes. Every time you need a new class. But what I said right now is to define lambda expressions, nothing but implementation of abstract method of functional interface. You don't require a separate class anytime. So that means you don't need any separate class. So that means lambda expressions are created in a block or method. I mean, generally method point of view I can take. Okay, lambda expressions are created in a block or method wherever we want. Inside a block or method, like wherever we want. Wherever we want, we can write lambda expressions. Are okay, lambda expressions are implemented. It's better to take this word instead of created. So lambda expressions are implemented inside a block. Block means if blocks or whatever, that is what I am taking. Method means regular methods. So inside a methods or inside a blocks, wherever we want, we can create our lambda expressions. So that means you don't need a separate class to provide the implementation of functional interface abstract method by using lambda expressions. If you are going with old approach, you have to create every time new class. Now I ask, no, I don't like this solution. I mean, okay, keep these two solutions as it is. I want one more solution for that abstract method. Then what you have to do? Again, you have to create one more class. But I'm saying right now, you don't need any classes to define the lambda expressions, and as well as lambda expressions, we are going to create or implement, okay, anywhere else wherever we want inside our methods or blocks or wherever it is. Simply I can say like methods wherever you want. Not only like that, lambda expressions are passed as a method argument also. As a method argument also. So it's little bit high, okay, little bit highly statement. We will understand it. So that means what I'm trying to say. For example, what is the passing method argument? If you have this method, right? Generally, yeah, if you go here, yeah, in this case, now I'm passing what? 10 comma 30 is a value. So this is what I'm saying like argument values. So passing 10 comma 30 as a argument values. That why I am passing 10 comma 30 value, integer value. So that's why integer values. So now in this case, what I'm trying to say is tomorrow, assume there is a method like this. Okay, integer, some method. I'm not writing whatever it is, method, whatever it is. Here, the method argument data type is functional interface. What it is? Functional interface. The argument type itself functional interface. So that means whenever you are calling this method or method, then in for this method, what you can do, you can pass lambda expression. So in this case, that means at argument level also you can define the lambda expressions. That is what I'm trying to say. To define lambda expressions, you don't need any extra classes. Lambda expressions you can create wherever you want for a functional interface point of view. We will see that how to create and all. Okay. So these are all stories we will understand step by step point of view. It will take one or two classes. I mean, it will take one more class also, not today. Okay, let's understand now. At least we will understand how to write now. Okay, so now this is the functional interface. Let's start writing the lambda expression for this functional interface. Now, what is the syntax I said? Method parameters. Okay. I said concentration should be always on this method, guys. Okay. Now, what are the method parameters available? So first you have to take the parenthesis braces. Parenthesis braces. Okay. And what are the method parameters available in this case? Integer comma integer. Okay, let's take like this. Integer a comma integer b. Followed by what is the syntax I given again? Array symbol. Okay. Array symbol. So hyphen greater than. So you have to write side by side, guys. Hyphen and array. I mean, so greater than symbol that both together becoming as a array symbol. Now after array symbol, what you have to do? Open the curly braces. And inside the curly braces, you have to provide the logic here. So I said like providing the logic here. So that means now you can write whatever the logic you want, like a regular point of view, like system.out.println doing addition, and then okay, so something like that, whatever you want to write logic. So here, and this method return type is what? Integer. So that means definitely this method has to return always a integer value. So you are going to make like return what is the values a plus b. So you are going to provide a lambda expression implementation in this way for this method. I know you can't understand within one example. I know that point. I am only telling you, but it needs a little bit attention and it needs a little bit more examples also. So this is the way you are going to create a lambda expression here. Again, what it is? A lambda expression, an implementation. So that means it's an implementation. This is an implementation of that method called as integer add int a comma int b method via you implemented via lambda expression point of view. You implemented via lambda expression point of view. Now how to execute this lambda expression? Now how to execute this lambda? Okay, you implemented somehow. Now how to execute? So if it is a class and a okay method point of view, what you did, you called a method here by created object for this class and you called this method. That is how you executed in a regular approach, in a old everyday approach. Now, but with respect to functional interface, how to execute it? Let's see here. First, let's implement it. What I will do, I'm deleting all the the classes what I created right away so that we can avoid the confusion. So, yeah. Now, if you observe, yeah, just a second, guys. Okay, sorry. Okay, now I have only functional interface. Now I have only functional interface. Let's take a class. See, class means you are not taking a implemented class. That's what the point here it is. Okay. For example, I'm taking calculator. I think, yeah, okay. So right now I said, right, to provide a lambda expression, you don't need the class. Class means inside classes only you'll write always lambda expression. It doesn't, what is my point is, generally what you did, you made like implements and like calci operator. This is the regular approach, old approach. But I said right now, you don't need an implementation class. In going further, the number of times you are providing implementation for this abstract method, for every new solution, you don't need a new class. And you don't need an implemented class also. Now, this class is not an implemented class of this interface. It's a normal class. That is what. Now, here I am writing the lambda expression. Now, here I am writing the lambda expression. So, how to write? Let's see here. Okay. So, what I said first, here you have to add one more thing also in the syntax level. I can add like this, what it is. Here, for which functional interface you are providing the lambda expression that you have to take. So that means functional interface name and followed by lambda expression name. E- okay, and followed by lambda expression name equal to. And then you have to provide the lambda expression here. Yeah. So this is how you are going to do that. So this comes under the lambda expression and it before equal to you have to make sure for which functional interface you are writing this lambda expression that you have to define here, and then here lambda expression name. So let's see here. Now for which functional interface I am doing calc operation. Calculator operation is the functional interface. Okay. And I said some name you have to use here. So some name, variable name, like generally we will, while creating the objects, we'll give object name, right? Reference name. So similarly, you can take something like add something like equal to. Now you are start writing the lambda expression. So that means you are providing an implementation for, okay, in a way like lambda expression for this functional interface. For this functional interface is nothing but you are providing implementation of this method here. So in this case, the moment you implement a lambda expression is nothing but finally you are writing implementation for this abstract method. That is how you have to take functional interface name here first and some expression name. Now understand here what you have to take as part of lambda expression, that abstract method parameters. How many you have? Two you have. What? Integer comma integer. Let's take as it is first. You can write more shortcut ways also, but we'll go step by step process. Now I taken method parameters and then I said what? Arrow symbol. Okay, implies. So that means arrow symbol, and I said take curly braces. And inside this curly braces, so I brought down curly braces, if you observe or not. You have to write the logic. What is the logic? The implementation of that abstract method. So now you can write the regular methods, whatever you provide logic, right? So that is how you can write like this sort of addition is happening, something like that. And integer c equal to, sorry, integer result equal to whatever it is, equal to value. So what is the argument names you taken? Value 1 comma value 2. Okay, let's take like this value 1. Now value 1 plus value 2. So now you got result. So that means what I am doing here, it is return result. Return result. See, this is how you are going to write down the lambda expressions. Now this, whatever I highlighted here, this is lambda expression. This lambda expression is nothing but this lambda expression written for the purpose of this functional interface abstract method. So that means the overall what you written of this one, this lambda expression is nothing but an implementation of an abstract method of this functional interface. So that means that lambda expression is representing finally an implementation of this abstract method. So this is how you are going to write down the lambda expressions. So this is how you have to write down the lambda expression. Now this is lambda expression 1. Sorry. So this is a lambda expression 1 here. It is. Okay. Now how to execute lambda expressions? It's only implementation. Now how to execute or call lambda expressions? Call lambda expressions. I'm telling you this will not understandable within one class. I'm only telling you it will take, you have to practice many examples. And I'll take many examples, don't worry. So how to execute or call lambda expression in this case? So what is our lambda expression name in this case? Add something you take, and you can take ABC, whatever it is, something like operation 1, whatever it is. Something you can take. Now, how to call lambda expressions is the concept, right? So in this case, how to call lambda expression is you have to take the lambda expression name. Okay, so that means you have to take lambda expression name, whatever you taken over there, dot, dot. that abstract method name, single abstract method name, single abstract method name, and followed by real values, argument values. Arguments means values. Now in this case, based on our example point of view, what is our abstract? So now this is how you implemented. Okay, let me copy this here. Ultimately, this is what we did for the above functional interface. Okay. So now how to call this means what is I said? Take the lambda expression name. What is the lambda expression name you provided? Operation. So let's take the operation, lambda expression name, operation, followed by method name, single abstract method. What is the single abstract method? Add, method name, add. So this overall, whatever I mentioned here, this overall lambda expression is completely an implementation of this abstract method only. Indirectly, you provided by using lambda expression implementation for this abstract method only. So that's why in this case, the method name will become add. Add. And then real values, arguments you have to pass. What are the argument values? 10 comma 20, something like I'm passing here. 10 comma 20, I'm passing here. Now in this case, this is returning always integer value. So if you want, you can take integer something like that, result or whatever it is. Like that you can take. Then you can, if you want, you can print it. So this is the way you are going to call the lambda expression. That is what I'm trying to say. Now let's see calling the lambda expression here itself. So what is my lambda expression name? Operation. And what is the method name? Add. Add method, and I'm passing value 20 comma 30 or whatever it is, 20 comma 80, like that. So now it is returning what? The moment this line is executed, immediately JVM jumps to this lambda expression. And it will execute this lambda expression, that this line will be printed, addition will happen, result will be written, and then integer, okay, result equal to sort of result, something like that. Now let's execute this program. See, addition is happening. So that means what executed now? Lambda expression is executed. So you call lambda expression name dot, what is this? Method name of single abstract method. Single abstract method name of functional interface, and then you have to pass these values. So the moment you are calling like this, what's happening in this case is, so whenever you are calling, automatically in this case, it will verify where this lambda expression is available. Yes, it is available. JVM goes here and start executing lambda expression. And what are the values you pass? 10 comma 20. So that means 10 comes here, 20 comes here. And then it will enter inside the lambda expression. And then it will start executing line by line. 10 plus 20, I mean, whatever the values you pass, 10 plus 20, 30, 30 is assigned back here. So you're returning again 30. So that means finally result will contain 30. It's a regular method approach only. So this is how you have to provide the implementation. But what is the real advantage of lambda expression here? It is, now I want new solution. I want this solution is okay. I want one more solution for the same method. In earlier what you did, the moment I said new solution along with existing solution, you created one more implemented class. But now see what I'm doing. Second solution, like whatever it is, I'm creating second lambda expression for the same functional interface. So that means calculation, what is that? Calc operation is the functional interface name, and operation to something, whatever it is, to equal to method parameters. So again same solution. What? Integer value 1 comma integer value 2, and followed by array symbol, curly braces, open the curly brace, okay, end with semicolon. In between you have to write the logic again. So in between again you are providing the logic. So here again you are writing your own logic, or return what, value 1 plus value 2. This out of second solution, whatever it is, just purpose I'm writing. Second solution. So now what happened? You are not created a new implemented class. For to implement that abstract method, you created one more implementation via lambda expression here itself. Now I want third solution. Yes. So give some different lambda expression name and then it will become third solution point of view. You can write your own logic. Now total you have three lambda expressions. That means three implementations for the same abstract method. So now you can call whatever you want. For example, here you called first one, right? I'll bring this to here, last line. So this is first approach. Now, second approach point of view, operation 2. See here I am calling lambda expression 2, operation 2, operation. So here I am operation 3, right? So similarly, operation 3. So I may pass different values or same. So overall what you have to understand. Total three implementations you are executing. Three implementations we provided. Three types of implementations we provided for the same abstract method without writing any extra classes. And even this class itself not any implemented class for this interface. So that is the advantage of lambda expressions. So you implemented functional interface abstract method logic as an expression. What is the expression in mathematic point of view? Generally, we will use a word called as expressions, mathematical expressions. In mathematics, generally what we used to call an expression means, for example, a equal to b plus c is an expression. So is an expression. That means a b value b plus c values are added and added assigned back to the c. So in this case, I am calling it as an expression. So that's why they given name as a lambda expression. So that means ultimately what you did in this case is you provided implementation for this abstract method in an expression format. In a simple, as a simple mathematical expression point of view, you provided the solution. And these solutions, you provided n number of solutions wherever you want. In another class tomorrow, you want to provide implementation for that abstract method. Yes, simply write one more lambda expression, define one more time lambda expression and provide your own solution and then start executing lambda expressions. So see here, total three lambda expressions executed now. First solution, second solution, third solution point of view, total three lambda expressions are executed. Three lambda expressions executed. Okay, so let's see. This is how you have to write. What I will do is I'm writing one more functional interface dot to. So understand again. Bank loan. Simple class name as a bank loan. I mean, sorry, interface name I'm going to take. Okay, now see here, this is not a functional interface because zero abstract methods. It's better to add always functional interface. Okay, cool. The moment you added why you got compile time error because zero abstract methods, right? Let's define a abstract method here. String get loan. I'll take like this double get EMI loan, get loan EMI value, something like that. So some parameters you can take here. Like last time we taken long principal amount, integer, number of months, duration, and then followed by rate of interest, right? So double rate of interest. Okay, so now I can call it as a functional interface. Now I'm calling it as a function because single abstract method. That's okay. Now let's start taking a new class again, or you can use previous class also. But it's not an implemented class. That is what you have to understand here it is. So you are not taking like implements, bank interface. No, you're not doing anything. You are writing directly wherever you want. You are writing an abstract methods. Now, sorry, lambda expressions. So I'm writing again lambda expression. Okay. So how to write lambda expression? I said for each interface you are writing point number one, bank loan. Okay. And from that bank loan, what is the method? What is the method? What is the single abstract method available in that bank loan? Copy this until you are getting familiarity. Copy, like, do like this, write comments. Okay. So that means you are going to write a lambda expression for this functional interface, and this functional interface internally have this abstract method. Cool. Now start writing the lambda. So what I said, the moment you are writing the lambda expression name, lambda expression, as per syntax, first take the functional interface name and then some name. Okay, let's see here. What is the functional interface name? Bank loan. Sorry. So what is the functional interface name? Bank loan. Bank loan. Okay, fine. And I'm writing like home loan. I can take any functional interface name. Now here parameters. How many parameters? One, two, three. And long int double. So if you want, you can copy paste for time being, or you can type your own also. Three parameters. Why? Because a subtract method is having three parameters, you have to take 300 percentage. Now, once you define the parameters, what you have to do? An array symbol. And then open the curly braces and end this curly brace, please, always with semicolon when you define lambda expressions. Okay. So now here you are going to write logic. What logic? Calculating the EMI value. So sys out of calculating home loan EMI value, something like that. And assume you are returning some value here, return some random value. I'm writing. Okay, I'm not writing that principles and all. If you have time, you can take that. So EMI value means, so for example, I got 55,000 as EMI value, something. Okay. So now what happened? You provided lambda expression again for this functional interface, and as part of this functional interface you provided what? Implementation for this abstract method. Now what is the lambda expression you provided? One. Now similarly I can provide any number of lambda expressions for a functional interface. Home loan, car loan. So calculating car loan EMI value, and assume finally you got something like 10,000 20,000 or whatever it is. So like this. Now total two functional interfaces you provided. Now how to execute this, sorry, lambda expressions? I said take the lambda expression name. For example, I want to see the home loan. See here it is a different solution. Here it is a car loan solution. Here it is a home loan solution. Now let's call the first of all home loan point of view I want. Okay, home loan dot, what you have to take? Method name. What is the method name? Get loan EMI value. The method name of abstract method is what? This one. And what you have to provide? Real values. So he is applying like for 50 lakhs, and then number of months he is looking for almost 150 months or whatever it is, and rate of interest he is looking for 10 percentage or whatever it is. So now what will happen once this entire logic, whatever you write on 100 lines, 200 lines or whatever it is, I mean whatever the logic you implemented, that everything will be executed. Finally you will get a loan value double EMI value like this. You are going to finally see that's what you are returning, right? Now let's print it. Right. Now similarly I want car loan value. So what you have to do? Again same approach. You are already have a lambda expression. Execute that lambda expression, car loan dot method name. What is the method name? Get loan EMI value. And what are the values you have to pass here? For example, I'm applying a loan for 10 lakhs, and then I'm looking for 60 months, and then I'm expecting at 8.5%. 75% or whatever, just like that. Now again, this entire logic based on the logic what you written, that will be executed, and finally some value will get it back. So let's take again EMI value equal to and print it. Sys out EMI value. So now what happened? Total two lambda expressions you provided. That means two types of implementation you provided for this single abstract method. And then you are using here and you are executing also. Now if I am asking, I want for the personal loan, you have to provide one more lambda expression here itself or somewhere else, but you are not creating a class. Now if I am asking same thing with respect to old solution, total three loans you have to implement, right? So for example, if I am asking same thing with respect to old solution point of view, I want logic for all car loan, home loan, house loan point of view. If it is old approach point of view for this interface, what, how many classes you have to create? 100% is tell me. I want logic for home loan, car loan, as well as personal loan. Then how many classes you would have created? If it is old approach, definitely three classes. Three implemented classes. Three implemented classes you have to provide. Why? Car loan implements bank loan. House loan implements bank loan. Personal loan implements bank loan. Then you will start overriding that methods with logic. Three implemented you have to take, and then you are going to make sure overriding that method. Now tomorrow my requirement is like, okay, you provided one implementation for the home loan. I want one more implementation for the home loan. Another solution for home loan only. That means what you have to do, again you will start creating a new class. Again you will start creating a new class. That means fourth class. You will add, you are going to write again fourth class. Total four classes you have. But here, if you want one more home loan solution, what you will do? Okay, let me write like that. Bank loan, home loan, second approach point of view equal to, and then you will take same approach, but you are making everything in one class. You are reducing the number of classes also. And what you are making, this you make solutions are very simple and you are writing in a very less amount of code. Here, in this case, four classes I written, but now in within one class I am able to write 10, 15, 20 implementations also. So that is the beauty of Lambda expressions with respect to functional interfaces. Not only this, you will understand so many other points going also like that. So what is my suggestion here? It is, please practice all these examples. I'll take few more examples in the next class and we can make shortcuts also for this. I'll give you that shortcuts so you can remove these data types and all. I'll come back to that. But we have to go in a step-by-step process. So I don't want to hurry worry in this case. I'll take one more class with few more functional interfaces and Lambda expression, and we will create lot of Lambda expressions by writing some shortcuts. Some rules are there. So if you are following that rules, you can make very lightweight Lambda expressions also, and we will try to understand how, okay, easily we can write Lambda expressions for the functional interfaces. We are already done today, but we will take more number of examples, and again I will explain in different ways. So that is what with respect to functional interfaces and Lambda expression. So in the overall concept, writing functional interface is not a that much big deal. It's a simple thing, but only thing is understanding the Lambda expressions and how you are writing Lambda expressions and how you are executing the Lambda expressions is the story you have to understand here. It is so very simple. If you make your note like this, then you can understand very easily. So simply what happening, you are providing Lambda expression for this interface. So that's why you take an interface name, Lambda expression name. And what is this or equal to this parameter section, these parameters section. Why this parameter section? Because you are providing implementation for this method only, right? You are providing overall implementation for this abstract method. So whenever you are providing an implementation for an abstract method, definitely you have to follow same order of the parameters. So that's the same order of the parameters. Only thing is you are not defining a method name here. That's all. And after that array symbol and curly braces, and in between that you will write logic. And this, in this case, curly brace will end with semicolon only for the lambda expression point of view. Because in this case, lambda expression is a statement. So expression is nothing but a statement. So every statement should end with semicolon. We know that rule. It's not okay. That is such a way lambda expression considered as a statement. So that's why lambda expression point of view, the moment you open curly braces, you have to end with semicolon also. Only in these scenarios. And in between that, you will write the logic. In between that, you will write the logic, whatever you want, like a regular method logic point of view, whatever you want. So with this lambda expression, writing lambda expression for functional interface is completed. Now the how you are executing means call that lambda expression name dot method name. What method name? Again this method name. Why this method name? Yes, that is what the implementation of you provided in a different approach called as lambda expression. Finally, method implementation only. But only thing is you taken a new name, new concept called as lambda expression. But ultimately what you did via lambda expression means you provided implementation for this abstract method only. So that's why you are taking, again in this case, expression name dot method name and the real values. Pass the real values, then automatically. So now total two lambda expressions. The moment you said home loan, it will go to the home loan lambda expression. The moment you said car loan, it will go to the car loan lambda expression. And these three values, okay, passed here, passed here, passed here. Then those values being used in the logic, and finally you will get return, and the return value you are getting it back here. So in this case, this is the lambda expression you're writing. Okay. So that's all for today.